Hello everybody. Today I can graph exponential and logarithmic functions by typing the equation into y equals and finding the asymptote. Let's get right to it. Number one, y equals 2 to the power of x minus 3. To graph anything, I go to y equals, I type in the equation 2 to the power of x minus 3, and I go to my table. Now, before we do that, the only thing that makes exponential and logarithmic graphs different is that there's an asymptote. The parent function for exponential looks like this, where it has a horizontal asymptote. It passes through 0, 1. It gets closer and closer and closer to the x-axis, but it never actually touches. So the asymptote will be whatever the vertical shift is of the graph. In this case, the vertical shift is going to be negative 3, so I know my asymptote is going to be y equals negative 3. It's a horizontal line, so it's y equals. It's going to be at the vertical shift. Now, that's mathematically how you determine the asymptote, but there is kind of a cheat. When I go to my table, I see that my y value is getting really, really close to negative 3, negative 2.75, negative 2.984, 2992, 2996, 2998, 2999, and then it says negative 3, negative 3, negative 3, negative 3, negative 3, negative 3. It's not negative 3. It never actually hits negative 3. It gets close, so close that the calculator rounds it to it. So that value that you see over and over again in your y column, do not plot those points. That's your asymptote. That's another way to determine that it's going to be y equals negative 3. So I'm going to put in the asymptote. I'm going to label it y equals negative 3. And now other than that, I'm just going to write down my nice points. So not the negative 3s, because those points aren't actually on the graph. I can deal with that negative 2.5. So I have negative 1, negative 2.5. You don't have to do the 0.5, but 0.5 is nice enough for me. I'm not going to do these weird decimals. I'm going to do 0, negative 2. 1, negative 1. Any nice point that's going to fit on the graph. I've got 2, 1, 3, 5. 4, 13 is not going to fit on my graph, so I'm not going to plot it. If I had a bigger graph and it fit, then I would. So I've got negative 1, negative 2.5, 0, negative 2, 1, negative 1, 2, 1, 3, 5. You can look at the calculator if you want to see what it's going to look like. Arrows, it cannot touch the asymptote. It should be getting closer and closer, but never touching. That's how we graph anything. Just plot the points like you would graph anything. And an exponential graph always has a horizontal asymptote. It's where the vertical shift is, or it's that value in the table that's repeated over and over and over again. It never actually does hit that. Do not plot those points. That's your asymptote. Domain and range. For any exponential graph, the domain is always going to be, is there graph out here or arrow pointing out here? Yes, negative infinity to positive infinity. The range for any exponential will be negative infinity to positive infinity. The range, is there graph down here? No. Again, it's getting closer and closer, but never touching that negative 3 value, so nothing. There's no value at negative 3, but immediately after negative 3 it starts, so it's negative 3 to infinity. But since there is no graph at negative 3 is not included, so it gets a parenthesis. The range will always include an infinity, whether it's positive infinity or negative infinity, depending if it's flipped or not. But you could always just do the domain and range. But domain for exponential will always be negative infinity to infinity. End behavior. As x approaches negative infinity, that's left. As I look to the left, well, the graph is not going into positive infinity. It's not going to negative infinity. It's getting closer and closer and closer to negative 3. So for exponential, one of the end behaviors will always be the asymptote. The other one, as I go to positive infinity, As I go to the right, the graph is pointing up to positive infinity. That's how I graph exponential. I plot the points just like I would do any graph. I need a horizontal asymptote. It's the vertical shift or the repeated value in the table. Domain's always negative infinity to infinity. Range is bottom to top. It'll vary depending on what's happening to the graph. And end behavior, one of them will be the asymptote, and the other one will be either positive infinity or negative infinity, depending on how it's transformed. Let's take a look at a log one now. Let's take a look at number 8. To graph anything, I type it into y equals. To type in log base alpha window 5, log base 3, x plus 2 minus 1. Before I go to the table, the parent function of a log graph has a vertical asymptote, passes through 1, 0, and looks like that. So what will affect the asymptote is a horizontal shift. This has a plus 2 being added to the x, which means the shift will be left 2. So my asymptote is going to be x equals negative 2. There is a trick to do it in the calculator. It's not the same trick as the exponential. You're going to see a bunch of errors. The last error, that's your asymptote. So my last error here is x equals negative 2. That's your asymptote. Now that's not going to work 100% of the time. If it's a decimal or a fraction, it will not work. You would have to do it as a horizontal shift. But as far as the questions that they've asked in the regions, it's never been the case where it's been a decimal. You've always been able to get it that way. So that's my asymptote. Now plot all your nice points. I see negative 1, negative 1, 1, 0. Negative 1, negative 1, 1, 0. You're probably not going to get more than 3 or maybe 4 points for the log graphs. Those are not nice. Those are not nice. Those are not nice. 7, 1 is nice. That's all I got. So let's get the asymptote on there first. X equals negative 2. That's going to guide the graph. I can't touch that line. It's going to get closer and closer to that line. Negative 1, negative 1, 1, 0, 7, 1. You can look at the graph. It's very misleading. It does not start in the middle of nowhere. It is going down, 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 down forever. Even though the calculator can't handle that, you can. Human brain is better than the calculator. So it's going to go down forever. It's going to have arrows. That is how I would graph it. Range is going to always be negative infinity to infinity for any log graph, similar to how exponential is negative infinity to infinity for domain. The range is negative infinity to infinity. The domain, similarly to the range of exponential, everything's going to be opposite. So it's going to have n infinity involved, depending on how it's transformed, whether it be positive or negative. The domain, nothing, nothing, nothing. It starts at negative 2, but not including negative 2, and goes to infinity. End behavior as x approaches negative 2. As I get closer and closer to negative 2, the graph is going down, down, down to negative infinity. And as x approaches positive infinity, as I go to the right, the graph is pointing right. It's also pointing up. That is positive infinity. So to graph anything, just type it into y equals and plot the points. Log is going to have a vertical asymptote at the horizontal shift, or it's the value in the table, the last error. Exponential has a horizontal. It will be that repeated value that you see over and over again. For any log, the range is negative infinity to infinity. For any domain, for any exponential, the domain is negative infinity to infinity. The range of exponential will have an infinity involved, as will the domain of the log. And the end behavior for exponential, one of them will be the asymptote, the other will be an infinity. And for log, they'll ask you, as x approaches the asymptote, it will either be negative infinity or positive infinity, depending on which way it's pointing. That really is nothing new as far as end behavior goes. So that's one of each. Practice it. It's not a hard lesson. It should be easy points on the regions. Type it into y equals, get your asymptote on your page, and from there you should be able to answer your follow-up questions. Practice. Goodbye. See you.